Hello dear friends, let us discuss 2-3 problems from design of V-belt. So kindly read the question. Select a V-belt drive to transmit 9 kW from a shaft rotating at 1200 rpm to a parallel shaft to run at 300 rpm. The diameter of the smaller pulley is 120 mm. The center distance is 1.2 meter. Okay, the data provided are very basic and there is no complications in this. So let us move directly into the design procedure. What is the initial step? We have to find out the unknown using the velocity ratio equation. Okay, so the unknown value is capital D. We got the value as 480 upon substitution. In the step number 2, we will be calculating the velocity. All the data are available to you and the value that we have obtained is 7.53 meter per second. Okay, now moving forward with the step number 3, we have to calculate the equivalent diameter. Okay, equivalent diameter is obtained using this particular equation. DE is equal to D into capital KD. This is given in the page number 295. Okay, so let us go and find out what is given in the page number 295, and along with that the KD value, the correction factor need to be added here. This factor is obtained from the table 14.15, which is there on the page number 340. Okay, now let us go and see what exactly is the data is provided there in the table number 14.15 and also there in the page number 295. Okay, so moving forward, so this is the page number 314 and there you can see the table number 14.14. 14.14 is something different that gives the classification that we will discuss later. Okay, here 14.15. okay, you can see the first column gives you the various ranges of velocity ratio or the speed ratio, and the correspondingly you have the value of KD here. Okay, now for this question the velocity ratio that we have is what? It is capital D by small d. The capital D was how much? The capital D that we have obtained is, the velocity ratio that we have obtained was 4, right? That means capital D by small d, 480 divided by 120 will give you the value as 4. Now you can see here the value, the velocity ratio value that is obtained is 4, which is beyond 2.949. okay, so for that we have to choose a value of 1.14 as the KD value. Okay, so this is how we are going to select the value of KD. If it is going beyond 2.949, you can stick on to the value of 1.14. that is how you are going to select the value of KD. And upon substitution, let us go back and see. Upon substitution, you are going to get the value of D as how much? 136.8 mm. Okay, now comes the selection of the cross section in step number 4, and this is stated as the equation number 14.13a to E. It is provided A to E. Okay, now let us go and see what exactly happens there in the equation 14.13. okay, so this is the equation 14.13a and 13b, 13c. okay, Now I hope you all remember the discussion. In the discussion part I have told you how the selection of cross section is being done based upon the value of D. Here the value of D that we have obtained right now is how much? 136.8. So for a value greater than 125, for a value greater than 125 and for a value which is less than 175, we have to select the cross section B. So for this question the cross section that we are going to select is B. Okay, so B is selected. Okay, so we will go for the equation of B for the calculation. This is the equation we are going to use for the calculation of power. This equation we are going to use. Okay, so I think that is clear. Now let us go back to the problem and see what is done over there. Okay, so we have selected this particular equation and upon substitution we got the value of the power rating as 2.11 kilowatt. Okay, now we have to move on to the next step, which is nothing but the calculation of number of belt. Okay, in the calculation of number of belt we are going to use the equation number 14.14 in the page number 295. Okay, that is the equation we are going to use. Okay, so now let us go and find out the equation and the corresponding substitutions. Okay, fine. So this is the equation that we are going to use. This is the equation that we are going to use. Okay, so in this equation capital P is there. What is capital P? Capital P is the power which is given in the question. In this question the power is given as 9 kilowatt. Okay, so that value is readily available as with us. Now we have to get the value of Ks, Kl and K. These are available there in the table number 14.19, 14.20 and 14.21. Okay, this small Kw we have already calculated in the previous step. Okay, so that is readily available with you. Now the important calculation we need to carry out is the Ks, Kl and K. So now let us move on to the table number 14.19 and see what is the values that we have to take. Okay. So let us go to the table number 14.19. Okay, this is the table number 14.19. Since there is nothing specified in the question, they haven't specified any of the operating condition. So what I will do, I will go and assume a medium duty. That is going to be my assumption. I am going to assume that the belt is a medium duty belt and it has got 10 hours to 16 hours. That is my assumption, and I am going to assume that it is type M. Okay, so if they want some other type, they have to specify that. With other than, if they have not specified anything like that, definitely it's our choice to select. Okay, so in this question I am going to select the type M and for over 10 hours to 16 hours. This is the selection I am going to make. So for that the corresponding value is this one, 1.2. Okay, this is how I am going to select. Suppose if they have specified any operating conditions or service conditions, you have to consider that for the selection. Okay, so this is how we are going to select the value of Ks. So that part is okay. Now let us move on to the table number 14.20 to get the correction factor value KL. Okay, so to get the correction factor KL, we need the nominal length of the belt drive is required. Okay, so length of the belt drive is required. So if you refer back to the solution part, I have calculated the pitch length using the equation 2c plus 1.557 d plus d, the equation number 14.15b. So while going to that particular page, I will explain that, but for the time being, you please keep this in mind. Okay, so in that, by using that equation, I have calculated the length, and the length I have obtained was 3370 mm. Okay, now let us see how we are going to select the value of K. Okay, so here The cross section that we have selected is B. So this, the third column, we are supposed to look through. Okay, so going through a value of 3370, but unfortunately you have the value only up to 2032. You don't have a value beyond 2032. So what you will do, see, and for corresponding 2032 there is no value given here also. So whatever might be the last value provided for this particular belt, you are supposed to select that 0.98, or it can be beyond that. So for the time being we can assume it as 1. The value is equal to 1. Okay, that is how I have selected the value of KL. KL is selected as how much? 1. This is the only reason. Okay, so if you don't have, suppose if it is a belt C, the last value is going to be how much? 0.87. So if your length of the belt drive is going to come beyond this, you have to take a slightly higher value above 0.87. Okay, anyway we cannot write it as 0, because if you write it as 0, the entire term is going to become 0 and infinity. So that is not a logical way of solving the design problem. So you have to select the value of KL like that. Okay, now moving forward, we have to get the value of KA. This one, this is the table 14.121. This is the KA. I hope you will go back to the solution part. The solution part, I have calculated the value of theta. Okay, using the equation pi minus capital D minus D by C. Okay, into 180 by pi. I will explain that there. But the value I have obtained is how much? 162.7. Okay, so the value I have obtained is 162.7. So now let us see how we will select. See, 162.7 is going to come just after 163, and the next higher value is 166. Okay, but you can see here it is 0.95 to 0.96. Anyway, you have got two columns, VV belt and V flat belt. Generally, if nothing is stated, we will be going for the VV belt. Okay, if they say anything regarding the pulley belt combination like V flat like that, you have to go for this third column, or else you have to go for the VV column. Okay, now see, the value is 1.63 and 1.66 here, but the angle of contact that we have obtained is 162.7. it is somewhat very close to 163. So you can go and get the value, select the value as 0.96, because the way it is can be approximated 163. Okay, exactly speaking, suppose if you have a value as 164, you are supposed to select a value in between 0.96 and 0.97. Okay, so you can go for the interpolation, or you can take a value in between these two, because the variation is very small. So even if you take a value which is going to come in the middle of 0.96 and 0.97, then also there will not be any kind of big variation in your answer. So please don't worry anything like that. Okay, standard method is nothing but interpolation, but if you don't know, or since this gap is very small, you can directly select the value from here without the interpolation itself. Okay, now let us go back. So we have got the value of KS, KL and KA by using this table. So this is the methodology. Okay, KS is based upon the service factor and KL is based upon the length of the belt. So you have to calculate the length, and K is based upon the angle of contact. You have to go for the angle of contact. Okay, so this much calculation has to be completed to get the values of KL and KA. Okay, now let us go back to the solution part. Okay, so coming here, see, I have calculated, as I have told you, I have calculated the pitch length. See, and the value I have obtained is 3370. This value I have used over there to calculate to find the value of KL, correction factor KL. Okay, and I have given it over here. KL is approximated as 0.98 and I have approximated it to 1. The variation is only 0.02, so it will not affect your answer much. Okay, then I have calculated the angle of contact, a smaller pulley. Okay, here on keep one thing in mind, you calculate the angle of contact of the smaller pulley. That is sufficient. Okay, for the smaller pulley. Okay, that is sufficient. So the equation which is provided in our data handbook is pi minus capital D minus small d by c, but I have added a 180 by pi here. I hope you can see it over here, 180 by pi. I hope you all know the reason for that. What is the reason? Because the value I am going to obtain here is in radians. I want to have a value in degree. To convert it to degree, I have added a 180 by pi. That is the only reason. Okay, so the k value is obtained here, and upon substitution, the n dash value I am going to get is how much? The n dash value I am going to get it as 5.33, and approximately it is equal to 6 belt, because you cannot have a belt number of belt 5.33. Either it should has to be 5 or it has to be 6. Anyway, we will be going for the higher value. That is logically that is the correct way of selection. Okay, so the total number of belt that is required to transmit this much amount of power is 6 number of belt. Okay, so in the design procedure, I have told you that you can wind up your design here, but still you can go beyond this, okay, to find out the cross section. This is also an important parameter, because during our introductory class I have told you we have got different cross section for the belt, and see the cross sectional value is constant. You cannot alter that because that is readily available, the industrial standards. Okay, so what we are going to do is we are just selecting a particular belt and we are finding all the essential values. Okay, so we are not going to alter the B and T. Now if you go to the table number 14.14, the cross section, you can have this. Okay, let us go to the table number 14.14 and see what is given over there. See here, this one, 14.14 for the cross section of B. All these values, these are constant values. Okay, so this is the value I have selected over there. This is the value, this column. Okay, that is being selected over there. Okay, and how, let us see how that is executed. See, please don't forget, this is a very important step. After the completion of the design calculation, you should draw a rough sketch and you should mark the dimensions. Okay, so you have the value of B and T here. So what I will do is I will calculate the value of sigma C. This is a very common equation. Centrifugal stress I will calculate, and I am going to get the value as 0.063 megapascal. Okay, and from the table 14.16 I am going to assume the value of alpha as 38. Okay, by using this alpha and this B and T, I can calculate the cross section of the trapezoidal section, and I am going to get an approximate value of A equal to 103.6. okay, and after that, using this area, I can calculate the value of sigma C. TC is nothing but sigma C into A, and also sigma T1 can also be obtained as sigma D into A. Okay, these two values I have obtained. Now I hope you all remember this equation. Okay, now let us go and see what is the speciality of that equation. There is something special with that equation, because okay, look here, this is the equation. This is the equation. Yes, 14.12. okay, all of you please make a note of this. 14.12, T1 minus Tc divided by T2 minus Tc is equal to e to the power of mu1 theta. That is very important. It is not mu theta, it is mu1 theta. You have to modify the mu value using this equation. Okay, so it is nothing but mu divided by sine alpha by 2. For in this question they have not specified the alpha value. So what you will do, you have to go to the table number 14.16 and assume an alpha value of 38 or 36, whatever might be the value given over there, you can assume, and you come back here, substitute it and get solved and find the value of mu1, and thereby you calculate it to the power of mu1 theta. Okay, so you have the value of t1, you have the value of tc, you have the value of e to the power of mu1 theta. The only unknown is t2, and you can get the value of t2 as 23.15. Okay, so that is how you can complete the all the design calculations. Okay, this constitute the calculation of all the parameters, including the tight side tension, slack side tension, everything. Okay, this particular step we have to execute after completing the step number 5. I hope this problem is very much clear. Now from the next question onwards, I am not going to solve these problems in detail. I will tell you what is the speciality, what kind of changes you have to make in your design. Okay, let us move forward and read the next question. A pulley 200 mm diameter rotating at 900 rpm has 6 grooves and drives another pulley of 500 mm diameter by means of V belt of cross section C. The center distance is 1500 mm. The drive has to work for 12 hours per day under medium shock. Find the power capacity of the drive. See, I think you might have understood what is the difference here. Here they haven't asked us to calculate the number of belt. Instead they have asked us to calculate the power capacity. For some data are special here. What are the special data? One is this, it has 6 grooves. What is the meaning of this? It means it has got 6 number of belt. So the final step that we were conducted in the previous question, the answer of that is initially given here. So you have to alter the design procedure. Okay, and also they have given the service condition as works for 12 hours per day under the medium shock. See, since this is given, you can have your service factor taken directly from the table number 14.19. Okay, now let us see how this design is executed. So the step number 1, finding the unknown value. The unknown value is capital N. It is going to be 360 rpm. The velocity is going to be 9.42. And what is the velocity ratio? Well, the velocity ratio is going to be 200 is the smaller d and 500 is the capital D. So 500 divided by 200. So 5 divided by 2, it is going to be 2.5. Okay, so velocity ratio is 2.5. Now step number 3, d is equal to small d into kd. So the kd value is going to be 1.14. What is the reason? Because the speed ratio is going beyond the value which is specified there in the table. So we will be selecting the value 1.14 and d is going to be 228. Okay, now based upon the value of 228, I think I have to explain that once again for your clarity. Let us move to the equation and see. Okay, this is equation. Okay, so the value is going to come greater than 175 and lesser than 300. So you are going to choose the cross section C and you have to use this particular equation for the calculation of kilowatt. Okay, so that is how you have to select. So here in this question, the second question, yes, the second question, okay, is the equation for the cross section C. Okay, and the value of kW kilowatt of the belt is going to be 5.26 kilowatt. Now the step number 2 actually was defined for calculating the number of belt, but here we have to calculate the power. So we can use the same equation. How? Because n dash is provided us, the value is 6. Ks, Kw, Ks, KL and KH we have to calculate. I hope you know how to do that. I will go for the calculation of Ks. I can directly take because service condition is provided there. So Ks directly you can take L value. The calculated length is 4114. So for this value I am going to get the value of KL as 0.87. This is also coming to the beyond the value which is given on your data handbook. So this is how I am going to select the value of KL and I will calculate the theta, and correspondingly I will go for the calculation of k, h as 0.97. So upon substituting here, the only parameter is what? The unknown parameter is what? This is the only unknown parameter, small p, that we are going to, not small p, capital P. The value is going to be 24.5 kilowatt. This is the value I have obtained. Okay, and what is the step after this? You have to calculate the T1, T2, TC, sigma 1, sigma C, all those things. That is same. And also don't forget to draw the cross section. Okay, that is very important. So this is the only change that is in this particular question. Okay, all the other steps are remain same. Substitution, the way in which we are going to find out the values, everything. This is the only change that we can expect. Now moving forward into the last question we are going to solve in the V-belt is this. Kindly read the question. Two shafts 1 meter apart are connected by V-belt to drive 90 kilowatt at 1200 rpm of a driver pulley of 300 mm effective diameter. Okay, the driven pulley rotates at 400 rpm, groove angle is 40 degree and coefficient of friction is 0.25, area of cross section is 400 mm square, permissible stress is 2.1 megapascal, density is 1100 kg per meter cube, and here also they have asked us to calculate the number of belt, but some specialty is there because lot number of datas compared to the previous questions. Here we have got a lot number of datas. What are the extra datas given? Groove angle they have given us 40 degree, coefficient of friction they have given us 0.25, and one of the most important data, area of the drive 400 mm square. So see, if we have the area given in the question, then definitely we have to alter the design procedure completely, because you cannot do it in the right way as we have explained in the procedure. Okay, in the procedure I have told you that if area or anything like that is provided, you cannot use particular equation, you have to opt some other equation. Okay, that I will show you. Okay, and they have given the permissible stress sigma d as 2.1 here. Okay, and the density as 1100. I hope you know the use of density. To find out the weight density, you have to multiply this 1100 by 9.81 to get the value of weight density in Newton per meter cube. Okay, now let us see what is the variation in the step number 1, say unknown value. Step number 2, calculating the velocity. See, from the step number 3 we are going to change the design procedure completely, because we are not going to go for the selection of this equivalent diameter, or we are not going to select the cross section. No, because since the reason, because this is nothing but here in this question they have given the value of A, area is provided, so you cannot compensate the design if you go for the step number 3 and 4, the conventional step number 3 and 4. So here we are going to alter. Okay, what is the alteration I have to give? I am going to use this time. I am going to calculate centrifugal stress. Why? Because I will be using the equation 14.16a for the calculation. Okay, so what is question number 14.16a? P is equal to n dash a divided by AV divided by 1000. We have to use this equation. Okay, this is used only when the area, cross-sectional area is given. Okay, please don't go for the calculation of n dash by the conventional means. This is how you have to solve it. So you have to calculate the value of a n dash. In the question they have given the value of a, we have the value of v, we know how to calculate the value of sigma c, and sigma d is given in the question. It's wrongly written here, it is not 2.26, it has to be 2.1. So kindly make that correction 2.1 and recalculate. This particular value I have obtained is based upon 2.26. Please rewrite this as 2.1. Okay, so mu dash, you have to modify this mu dash value. So what is the value? Mu divided by sine alpha by 2. Alpha is the angle, groove angle, and that is given as 40. 40 by 2 you are going to get the value of sine 20. So the mu dash value is going to be 0.73, much higher than mu. Okay, on substitute you will get the value of mu dash theta. So you will calculate e to the power of mu dash theta, it is going to 6.36. Upon substitution, you are going to get the value of n dash as 7.57. Maybe some correction will be there if you change this to 2.1. You can have some change. Sometimes it can be 7, it can be 6. Anyway, please make that correction. I have wrongly written this as 2.26. It is 2.1 because the value is given as 2.1, or this is the value as I have assumed. Okay. Anyway, so I will get the value of n dash. So, and after that I will calculate the value of L. Okay, so this is the last question, was a special question. So kindly make a note the changes that we have done here. So in this last question we have altered the design procedure completely, and I hope you all are very clear with the reason for that, because A is provided. Okay, in the design procedure also I have explained the same thing. Okay, so that's all. By this 3 problems I'm concluding this design of V-belt. So kindly practice all these questions, and along with that I will give you some practice questions to solve. So design of V-belt is very simple. Okay, this is a design for conventional type of classical type of V-belt. We are not going for the design of any other type. This is more than sufficient for you to understand the selection and design of other type of V-belt. Okay, so by this I am concluding, and thank you for your time.